Rearrangement reactions, hydride shifts. There are some methods of rearrangements. Here is the list of hydrogen shift, hydride shifts. The name are same: alkyl shift, phenyl shift, re-expansion, ring contractions. First of all, I will explain this hydride shift. Hydride shifts means hydrogen shift. Whenever the carbocation is formed and there is a possibility to become a more stable carbocation after the formation of carbocation, then if there is a hydrogen is there in the place where more stable carbocation is possible, then then the hydrogens will shift to the carbocations, and this process is called hydride shift. I'll explain by the example. Suppose this bromine, when H2O will like in this format, this bromine will attack to the, this will minus, it become minus will attack to the this, and this will go to the this will form a minus, which minus will form. After this is form a carbocation. This is a carbocation is formed. It is a carbocations and in normal substitution reactions, it has not I want to say that it will not go in rearrangement. If not go in rearrangement, then the product will form. After this, OH will attack to this, and the final product will be formed like this. In this position the OH will come. But substitution with the rearrangement, if the substitution reactions occur with the rearrangement, means this bromine will leave to this positions, this become minus, this become plus, this OH will like this. In this format it will live like this, and it will break, and this will form minus charge, and this here plus charge is formed. This plus charge carbocation is formed. Here is a one hydrogens. In this position it is a secondary carbocation. If it is come in this position, it will be tertiary carbocation. Then this hydrogens will shift to this position, and this carbocation will come to this positions. Now this carbocation is formed. After this, the structure will be like this. Here is hydrogens, here is a carbocation. Now this OH minus will attack to these positions, and this OH will come to this position. Now the final structure will be like this. This hydrogens, this blue hydrogens is initially in this positions, but after the rearrangement this hydrogen go to these positions. Here this position is shown. In this way the rearrangement is occur. If there is a possibility to become more stable carbocation, then the rearrangement is possible. In these compounds also rearrangement is possible, but I want to make some difference that after rearrangement the product, what is the product, without rearrangement what is the product. Here this OH will be in the, OH in second position, but this OH in the third position after the rearrangement. So rearrangement is possible if carbocation is intermediate wants to become more stable, it will rearrange. If there is a possibility to become a more stable carbocation, then there is a rearrangement is possible. In this examples, here is a primary carbocation, this is a secondary carbocation, this is a tertiary carbocation. If primary carbocation is there, it will rearrange to become a more stable carbocations by this hydrogen shift. Hydrogen will shift to this position, this H will shift to this position, and the secondary carbocation is formed. So in this way there is a possibility to rearrangement. Tertiary carbocation is more stable than the secondary, than the primary. So if any secondary carbocation is there forming a secondary carbocation, and there is a possibility to become a more stable carbocation as a tertiary carbocation, then there is a possibility to become a more stable carbocation, and the rearrangement is possible by the hydrogen shift. If there is a hydrogen, then the hydrogens will shift. If there is a methyl, then methyl will shift. The phenyl will shift. But here I am discussing about the case of hydrogen shift. Here is the carbocation is formed. Here is a hydrogen, here is a methyl, here is a methyl. But if 3 methyl will be there, then the methyl will shift. But here is a 1 hydrogen, 3 methyl. So first of all we should consider hydrogen shift. Then after methyl shift, then after methyl shift. But here is a hydrogen, so hydrogen will shift to this position. This hydrogen shift to this position. This plus charge will go to this position. Now the plus charge will go. This is a transit state. Means slowly plus charge will go to this positions. Now the plus charge in the right side. Now it will come middle side. Then after it come to the left side. After this it will break. It will completely break, and this plus charge will shift to these positions. Now this is secondary carbocation. Here is the primary. This is a primary carbocation. This is hydrogens will shift to these positions, and this carbocation will shift to this position. This is become secondary carbocation. This is a more stable. So in this way, if there is a possibility to become more stable carbocation, then more stable carbocation is formed. Now if the structure will be like this, if this is a structure, this is a secondary carbocation. Here if carbocation, here is a hydrogens, here is a hydrogens. If if anyone is student thinking that this hydrogen will shift to these positions and this product will form, not, it is not correct, because secondary carbon here it is forming primary carbon, so it will not rearrange from this structure to this structure. From this structure, this structure is possible, this is a right, but this is a wrong. Why? This is a primary carbon, here is secondary carbon. After the rearrangement, secondary carbon will be formed, then that rearrangement is possible. Here is the primary carbon, after the rearrangement it become a tertiary carbon. Here hydrogens will shift, this hydrogens will shift, it become a tertiary carbon. So when hydrogens will shift, when there is a possibility to become a more stable carbon, then the hydrogens will shift. Here in this case, hydrogen will shift to these positions. Here is not a primary, it is not a secondary, it is not a case of primary secondary, it is a case of allylic. This is if the carbocation will come to this position, then it will form a allylic carbocation. Allylic carbocation is more stable than the secondary carbocations. In the carbocation stability order, I have already explained that allylic carbocation is more stable than the secondary carbocation. That's why this hydrogens will shift to this position, this plus charge come to this position. Here this final structure is forming, this is a allylic carbocations. Here it is adjacent carbon to the double bonds has a plus charge, that is called the allylic carbon. So the allylic carbon is more stable, so the rearrangement is possible. Now in these structures, here is the bromine will leave, higher plus charge is formed. Here plus charge is secondary carbons. If plus charge will come to this position, it become a tertiary carbon. So it will break and this plus charge is formed, and now this H will shift to these positions. This H will shift to this position and plus charge will come to this position. This plus charge is coming to these positions. A bromine minus is remain in the solution. All these reactions are happening in the solution, not in the open condition, not in open atmosphere. Actually this is reaction happening in the solution. So bromine will leave this places and remain in the outside some area. In some circumstances, bromine will leave like bromine minus. When H2O, this is a solution, H2O is a solvent. When H2O is a lone pair, this lone pair will attack to this carbocation, electron deficient carbocation, lone pair will attack to this positions, and now OH will attach. Now OH will gain a plus charge. OH is gaining a plus charge. Now in solution there is a not only one H2O, not only one water molecule. In a solvent there is a some amount of water molecules. Here is one molecule is attacked. Now after second water molecule will attack to the hydrogens. This become a, it is a plus charge, it will try to stabilize, so it will break the bonds and become O stable. Plus charge will be beneficial and it become a plus charge. H will plus charge, this lone pair will attack to this, and H3O plus charge will be forming. Now H3O plus charge will be formed. After this OH will attack, and this H3O will in this format, and bromine will be minus. This H3O means H2O will form and HBr will form. HBr will be formed from this product. Now this is the final product which whatever we are getting after the rearrangement. So rearrangement is possible. Similarly in these structures, this is a CH3OH. It is similar to the H. This is a similar, approximately similar structure. So in this case also bromine will leave as a minus, and this minus will attack to the this H, and this will leave as a O minus. This O minus here become plus charge. This is secondary. Now here is a one methyl is there. This methyl to shift to this position, this plus charge will come to this position. This is a plus charge. This plus charge will be attacked by this CH3O minus. Here CH3O minus, O will attach to these positions because O as a terminal minus charge. So this is the final product we are getting. I will make more clear structures to make you more clear. This is bromine minus and it is a CH3OH. This bromine will leave as a minus, and this minus will attack to the this H. It will leave as a minus. Now the structure will be like this plus charge and CH3O minus. Now it is already from a HBr product. This is already from a HBr product. This is our side product. We did not need to consider about the side product. We have to consider the main product. Now this plus charge is secondary. Now here is a one hydrogens. This hydrogens will shift to these positions, and this plus charge will shift to this position. Our product will be plus charge. Here will be hydrogens. Now it is attacked by CH3O minus. This O minus will attack to these positions. Our final product will be OCH3. Here in this side OCH3 so on anyone side we can, so it is not it is not much important. Anywhere we can show this OCH3, but it is a good way to show this in this way, because of it will be less hindrance than less, it is a less hindrance position, so it is shown in this position. So it is okay, this is a fine. In this way the reaction is going on. Similarly this reaction also going on. This is a O minus, this is a H Br. This O minus will attack to this position and Br will be minus, it become a plus. This plus charge will, here is a hydrogen, this plus charge will shift to this position. This position H plus will come to this positions. Now this H plus will attacked by a bromine minus. Now the final structure will be like this. Here is also Br minus will leave as a minus, is a H2 will be like in this format, and this Br minus will attack to this position. This will break, this become a minus charge, it become plus charge. But this plus charge, here is a hydrogens, here hydrogens will shift to this position, plus charge will come to this positions. This OH minus, this OH minus can attack to this positions. Now this OH will come in this positions. In this position the plus charge will be in conjugation with this compound, so it will be more stable. That's why plus charge will shift to these positions, it will become more stable carbocation. In this way the hydrogen shifts are occurring. Here is the SN1 reaction is shown. SN reaction, all of these things I will explain later. Only I want to make clear about the hydrogen shift, how the hydrogens are shifting to become more stable carbocation. Here two product is shown. One is this is a minor product, this is a major product. How this minor product and major product is forming? This is a OH minus, this is a HCl. HCl will be like in this format. This OH minus leave as a minus, and this minus will attack to the this H, and it will break, it will acquire a minus charge. Here the carbocation is formed. Here is CH3, C, CH3, C, CH3. This is H. Here carbocation is formed. This carbocation is a secondary carbocation. If this carbocation will come to this position, it will become a tertiary carbocations. But here is a secondary carbocations. Here one CH3, one C, two side. This is a secondary carbocations. If any, by the any means, if this carbocation shift to this position, it will become tertiary carbocations. So it will try to rearrange. But if this Cl is a minus, Cl if attack these positions, then Cl product will be formed. This product will be formed. This is a minor product. Because why this is a minor product? Because this is a less stable carbocation. If this carbocation will shift to this position, if this hydrogen shift will occur, this carbocation come to this position. CH3, C plus charge, CH3, C, CH3 and H. If this carbocation will come to this position, and here Cl will be attacked, here Cl will be attacked, then this product will form. This is a major product, this is a minor product. This is a why minor product? Because it is a attacked Cl is attacking the less carbocation, less stable carbocation. Here Cl is attacking more stable carbocation, so that the whatever the product will form by this carbocation will be the major product. Whatever the product will form by this carbocation, secondary carbocation, it will be the minor product. So in this way, this is a major product, this is a minor product. By the hydrogen shift, how the major minor product is forming. Here is the structure, same thing is shown in these structures. Now also in these positions, this is a minus charge, this is H3O plus, H3O plus. It will, how it will be like H2O. This is a alkene. When this H2O, it will break bond like this. It will become H2O, it will become H plus. This is become H plus. Now this H plus will attack to this alkene. How the alkene will shift? This way, this alkene will form. Here is a minus charge, here is a plus charge. Why the arrow will come to this position? Why this pair of electrons shift to this positions? Why this bond will shift to this positions? Because if here carbocation will, if this way, in this way shift, then here carbocation will form. This carbocation is a more stable carbocation than this. If it's this structure like this. If in this way the shift, then the minus charge have plus charge will form. This plus charge will be less stable. This plus charge will be more stable. That's why this will shift to this position. Now this will become plus charge. This is a plus charge. Here is a minus. So this H plus, this minus will attack to the this H plus. This will attack to the H plus, and here the final product will be formed like a. In this way, the product may be formed. But here in this way the product may be formed. This is a possible, but there is also one possible case. Now in this way, this is a H is forming. Now here is the this H this minus charge will attack to the H, but here is also one plus. We need to be think about this plus. This plus is a secondary plus. Here is a carbon, here is carbon, here is a carbon. This is a secondary carbon. But if this plus charge will come to this position, it will become a tertiary carbon. Here is the one hydrogen is there. This maybe this hydrogens can be shown in the upper side, lower side, anyway. You can, it is not our much important, but let's, it will make our this. Here this is a plus H. This H will shift to this position, hydrogen shift will occur, this plus charge will come to this positions. After this plus charge, this is a hydrogen, here this plus charge will come to this position. Here the hydrogen is this. Now this plus charge in the solution, there is a H2O. H2O is the solution. Now this H2O, how will be like this? H. This is a lone pair. This lone pair will attack to these positions. Now after the attacking, the structure, whatever the structure will be formed, the structure will be formed like a this structure. It will become a plus charge. It will become a plus charge, but in the solutions only not H2O is there. In a solution maybe 2, 3, 5, 6, 7, 8, any some amount of H2O is there, water molecule is there. So one H2O is attack. Now after that, this is a plus charge, it will try to become a stable. Now this will break a bond, it will become a stable, this will become plus charge. This is a lone pair. This lone pair will attack to this plus charge. Now the H2O S3O plus charge is a, our side product will be formed. Now the final product will be, this is a side product will be formed, and the final product will be, this is our final product. OH is our final product. Here OH is our final product is formed. So here three structures are shown. This is our final structure. This is similar to this structure. Here in the downward side direction I have shown, but it may be in the upward directions. We can show in the upward directions. We can show this is OH in the upward directions. This is our this structures. So here this will be the minor product, this will be the minor product. As this is a plus charge will be also forming here. In this position also OH will attack, and this OH will attack, and this product will form. This is a minor. Why this is a more stable carbocation, so it will be the major product, this will be the minor product. Here is also there is a possibility to become a become minus charge. If this shift the pi bond in this manner, then here plus charge will form, here OH will be attack, and this product is formed. So this is a minor product. This is a minor, this is a less stable carbocation, this is also less stable carbocation. So this is our minor product, but this is a more stable carbocation. Here the more stable carbocation is formed. So this is whatever the structure formed by this will be our major product. This is our major product. This is a similar case. This is a similar case. Whatever the your product forming, this is a similar case. H3O will be attack. H3O plus will be attack. Here the OH will be formed. This is our the major product. This is the same case. Here is the carbocation is formed. This is a primary carbocation. This carbocation will become to this position. Then that will be more stable carbocation. So this is a hydrogen. So hydrogen shift will be occur, and this hydrogen shift in the transit state, this is slowly shifted. This will become a minus, and this will become a plus. So now finally CH and C, this will shift to this position, and it will acquire a plus charge. This carbocation will be formed. Now this is a phenyl, two phenyl, one hydrogens. This is a carbocation. If this carbocation is shift to this position, it will become a more stable. So phenyl is there, hydrogen is there. So hydrogen will shift first, then after then after phenyl, then after another compounds can shift. This is hydrogen shift will occur. Here is a hydrogen in this. I have shown in this place, but it may be can be shown like this place, and this will shift to this positions, and here carbocation will form as CH2 will be formed. Here I have shown this way. This is shifting these positions, and here carbocation will be formed. Here is also this is hydrogen. Here is a plus charge. This way this will shift to these positions. It will come to these positions. It will become a, here the step manner I have shown. It will shift to this position. Now H will come to these positions. This is a wrong. Need to be take care. This is a wrong. But here in this In this way the hydrogens can shift, here is also hydrogens can shift, but which one will be more stable, it will, you have to think. Here is a three, here is a, if this carbocation will come to these positions, it will become a tertiary carbocation, but if the carbocation will come to this position by this shifting, then this carbocation will form, this will be more stable. Why this is more stable? This carbocation is resonance with this oxygen level pair, so resonance will be more stable than the tertiary carbocations. That's why this, it is wrong, it is right. This hydrogens will shift to these positions and it will become a positive charge. Here the carbocation will shift, and here this carbocation will shift. Here this plus charge will come to these positions. Now this plus charge will come to this position. This is a more stable. Now similarly, here is a plus charge. Here is the CH1 CH is in this place. Here is H. In where will we shift? There is a two possibility to shift. Here in this structure I have shown, there is a major product and minor product will be formed. If this hydrogens will shift, here is a one hydrogens. Here is one hydrogens. If this will be shift, if this hydrogens will shift to these positions, here in this example the structure is, it is actually wrong. In this place not H plus, actually plus is there. There is no two possibility to shift. Here is the, it carbocation may shift in this way, carbocation may shift in this way by the hydrogen shift. Which one will be our major product? If this carbocation shift to this position, this hydrogen will shift to this positions, carbocation shift to this position. Now the carbocation is in this positions, carbocation is in this positions. This is a major product because here is a phenyl. Phenyl will stabilize by this conjugation, by the resonance it will stabilize. If the carbocation will shift to this position, if the carbocation will shift to this position, this H will go to this positions. Now this plus charge will form. This plus charge is tertiary carbocation, but this is a minus because it will provide conjugation with the phenyl carbocation. It will more stable than the tertiary carbocations. So this will be our major product, this will be our minor product. Now this, in this way, here is the carbocation. If this hydrogens will shift to this position, it plus charge will come to this position and plus charge will be formed. It will be a more stable carbocation than this position by the hydrogen shift. This is occurring. This is also, here is a carbocation. If this hydrogen will shift to this positions, carbocation will come to this position. This will be the more stable carbocation. In this way, the hydrogen shift occurring. The hydrogen shift and alkyl shift are the similar. There is a hydrogen, there is a shifting. Now we will learn about the methyl shift.